Okay. On a recent calculus experiment, that's what I do in my free time. I gave a student the instructions, start anywhere on Highway 75 between McKinney and Plano to begin going either the north or south direction, but you must always drive at a non-constant speed. You must change directions at least once, and you can only drive for 5 minutes. Measure the distance in miles and the time in minutes, okay? So I don't know if you know this, but I have 2 cars. One, I drive to work. My other car is a Ferrari. I don't like to bring it to school because the way you people drive in the parking lots and the buses and all that, it might be here. But I take it out on the weekends for a little, you know, calculus joyriding. So here we go. Let's say I'm in my little calculus Ferrari. It's a convertible, of course. You know, I need wind whipping through my hair. I'm driving on 75 in my Ferrari. So I start here now, and I'm driving this way, and then I change directions and go back this way, all the way to McKinney, and then I change directions again. This equation, S of t, physics people, it's my what? It's
velocity.
my
Velocity.
Try again.
Acceleration.
Position function. And my velocity equation is, how do I get the velocity equation from the position? When in doubt, we take the derivative. So my derivative in this instance would be 3t squared minus 12t plus 7. Okay, so velocity is the derivative of position. What's the derivative of velocity? Acceleration. Okay, so A of t, I'm going to take the derivative of the velocity equation. Derivative of the velocity equation is going to be 6t minus 12. And so this would be my second derivative. The derivative of the derivative. Okay, so I'm going to take just a second and just kind of give you a brief introduction to these 3 things so that you can have a better understanding of what they are doing. Okay, what's going on. So, position tells me where I am. Velocity shows me 2 things. Shows me speed, and it also shows direction. For our purposes, either positive or negative. If the particle is moving left and right, positive is moving to the right, negative is moving to the left. Perhaps it's moving up and down, okay, same thing, okay? So position shows me where I am. Velocity shows me how fast I am moving and in which direction. And then sometimes students don't fundamentally understand the difference between acceleration and velocity, but here's how I explain it. Okay, let's say my good friend Joe is driving in his car on 75 and he has the cruise control on. Is he moving? Yes, but, okay, so he is moving. He does have a velocity, but he does not have
acceleration.
It's a constant velocity, okay? So he is not accelerating. So when Joe's going 55 in the left-hand lane of 75, right, and doesn't even care to get over to the far lane, and Newhouse comes along in his convertible Ferrari, I'm gonna switch over, shift into fifth gear and blow by him. And so now I am accelerating past him, right? And I step on the gas, or it's also known as the accelerator, right? And so when you step on the gas or the accelerator, your velocity is increasing, okay? I'm getting faster, right? So velocity is like being on cruise control. I'm still moving, right? But my change of velocity is constant. The rate of change of my velocity is constant. However, when I step on the gas, then the rate of change of my velocity in this case is increasing. Okay? So let's say that I have my position function here. How would I find the velocity from this graph? Okay, and how do I find the derivative? By looking at the graph. It's the slope. So whenever I have a positive slope, I would be moving. Velocity shows direction. Also, whenever I have a positive slope, I would be moving forward. So I'm moving forward over here and over here. And whenever my slope is negative, I would be moving backwards. In this case, to the left. And what is happening right here?
You're turning around.
Okay, what's my velocity right here? My velocity is 0 because what's the slope? I have a horizontal tangent line there, right? So my slope is 0. I also have a slope of 0 right here. So my velocity is 0. And so I'm changing directions.
Is it differentiable though?
It is.
Since it's like
Because-
the same equation?
Because it is not a corner. Okay, it's a nice, smooth, rounded curve. So yes, it is differentiable at that point. Okay. So let's look at this. It says determine the position of the car at t is equal to 0, t is equal to 1 minutes if the car's path is modeled by the line y is equal to 3. So I have S of t equals t cubed minus 6t squared plus 7t plus 3. That's my position equation. And they asked me to evaluate my position at my initial position, which is t is equal to 0. So I would plug in 0 for t, and that goes away, that goes away, and that goes away, and so I get 3. And then they also asked me to evaluate my position at 1. So I'm going to plug in 1. That's going to give me 1 minus 6 plus 7 plus 3, which is 5. So the position of the car at t is equal to 0 is 3, 3. And at t equals 1, it's going to be 5, 3. Y, the y value is always going to be 3 because that was given to me. It's moving on a horizontal line there. Okay, so that's why I have 3 for y. Okay, all good so far. I just plugged in 0 and plugged in 1 to my position. Part B says determine the velocity of the car at t is equal to 2 and t is equal to 5. So now I'm going to use my velocity equation, which is again, it is the derivative of the position. So my derivative is 3t squared minus 12t plus 7. And I want to find v of 2. So I'm going to take 2 and plug that into my velocity equation. That's going to give me, let's see, 12 minus 24 plus 7, which is -5. So I'm moving in the negative direction, or to the left in this case. And what are my units? Be careful. What do they give me? Positions measured in miles, right? Time, in this case, is measured in minutes. How do we know? It's given. The problem says so. Okay, and so now I'm going to find V of 5. So I'm going to plug 5 into my velocity equation. Let's see, that gives me 75 minus 60, which is 15, plus 7 is 22. And again, miles per minute. So far, so good. Anything you want to ask me?
Where did you plug in the 5 in the equation?
They asked me to evaluate the velocity at t is equal to 5, so I took 5 and plugged it into the velocity equation. And so that's going to give me 75 minus 60, which is 15, plus 7, which is 22. Okay. Okay, part C says, determine what time or times the car changed direction. And the second part of the question is, what is the acceleration of the car at these times? Okay, so again, look at my little graph here. We wrote down that it was moving forward and then it's moving backward. So at some point it changed direction. And we know that it's going to change direction right here whenever the velocity is 0. So I need to find when the velocity is 0. But first, let me write this down. Car changes direction when velocity equals 0 and changes signs. So how would a card-carrying calculus slacker find when the velocity is equal to 0? I don't want factoring or quadratic formulas or anything like that. I want calculator, right? So get your little calculator. Do you have one?
Yeah.
And I'm going to take the velocity equation and set it equal to 0. So how about we graph it and find where it crosses the x-axis? Can we do that? And you should get 2 points. This is a parabola that crosses the x-axis twice. And so I'm going to have 2 different times. Can somebody help me out with the first time? 3. 0.709. That's in minutes, correct. And the second time, 3.291. Okay. And now I'm going to answer the second part of the question, which says, what is the acceleration of the car at these times? So take your calculator, and this time we're going to use our acceleration equation, which is 6t minus 12. And I'm going to plug in 0.709 for that. And then I'm going to plug in 3.291 into my acceleration equation. Okay, so if you put your acceleration equation into y equals, you can go to table set, which is second window on your calculator, and set the table to start at 0.709. And then it will give you the value, or you can just plug it into the equation. Either way. And so somebody help me out. What is A of 0.709? Did we get it? Should be negative. -7. Okay, that's it. Should be -7.746. Make sure you are plugging it into the acceleration equation, which is 6t minus 12. And what is A of 3.291? It's positive 7.746. And what would my units be for the acceleration?
Miles per minute squared.
Miles per minute squared. Okay. So I found where the velocity was equal to 0 by graphing the velocity equation, setting it equal to 0. And so I found where it crosses the x-axis at those 2 times. And then I took the 2 times, plugged them into my acceleration formula, and got those values. Okay. So now it asks, what is the total distance the car traveled for, it should say the first 5 minutes. And let me tell you what you can't do. I can't just find S of 5. Okay, and so here's why. Let's say I'm going to start right here. I'm starting at 3. I'm in my little calculus Ferrari. You're not as cool as I am. I travel this way. And then at 0.709 minutes, I'm going to make an instantaneous U-turn on 75. And then I'm traveling this way. And then at 3.291 minutes, I want to make another instantaneous U-turn. And now I'm traveling back this way. And after 5 minutes, I'm right here. So if I were to find S of 5, that would tell me where I am right now. It's my position at 5. But that is not the same thing as how far I travel, because I went all the way over there, and then I went all the way back here, and then I came back here. So how do I find my total distance? Physics people don't say the area under the curve, because that's next semester. So how do we find the total distance? How about, let's do this. Where do we start? S of 0. Let me finish my phrase here, though. I can't just find S of 5 because that will give me the position of the car at 5. Should say T. Position of the car at T is equal to 5. Okay, so I'm going to find where I start. What was S of 0? We already found it. S of 0 was 3. Okay, so again, I'm going to drive in my calculus Ferrari this way, and then I change directions. So I need to find where I am right now and calculate that distance between where I started and where I changed directions. Does that make sense? And where did I change direction? At what time did I change directions. I found it. It was 0.709. So I need to find my position at 0.709. So take your calculator, go to the position equation, which is the original equation that they gave us, t cubed, the cubic equation, and find the value of s of 0.709. Do that for me right now. And help me out. Colby, you get it?
5.3303.
Okay, that is what I got. So look, I started at 3, and then after 0.709 minutes, I changed directions, and I was at 5.303, meaning I traveled 2.303 miles during that interval. Everybody okay with that? So I start here at 3, I travel this way, 2.303 miles, and then I'm turning around and I'm traveling over there. So I go again from, I've got S of 7.09, it was 5.303, and I changed directions again at 3.291. So find my position at 3.291. Take your calculator, plug that in. And somebody help me out. You got negative 3.303. And so how far did I travel? Be careful, be careful, be careful, be careful.
606.
I went from 5.303 to negative 3.303. Therefore, I traveled 8.606. Careful. Positive 5.303 to negative 3.303 is a distance of 8.606. Okay. And then one more. Okay, I went from S of 3.291. That was negative 3.303. And they wanted me to find where I was after 5 minutes. So I need to find S of 5. I'll give that to you. S of 5 was 13, I believe. And so how far did I travel? I went from negative 3.303 to 13, which is 16.303 miles. Okay, so I kind of ran out of room there, but here's how I find the total distance. Total distance, I'm going to add up those 3 things, those 3 intervals, how far I traveled during those 3 intervals. So 2.303 plus 8.606 plus 16.303 gives me a total distance of 27.212 miles. Okay. Questions or anything so far? Please ask me now.
Where did you get S5 from?
It was given because right here they wanted me to find the total distance at 5 minutes. So that is my ending time. So I found my position of S of 5. So if you take 5 and plug it into the original equation, you should get 13. I gave that to you. But you can find it using your calculator. Okay? Okay? We all good? All right. Well, I need to do a little illustration. So, Jackson, thank you for volunteering. Happy to be here. Come on down, my friend. Let me set this right here so the people at home follow along. Up here, please. Okay. So, the reason that I do this is so that a couple months from now, when I ask you a question and half of you miss it, I'm gonna say, remember when I brought Jackson up to the front of the room and did this little illustration? Yeah, okay. So here we go. Jackson is representing the velocity. I am representing the acceleration. Okay, so if Jackson, as the velocity is moving to the right, and I am also moving to the right, move to the right. Okay, move to the right, move to the right, move to the right. If we are both moving to the right, he is speeding up. Now move to the left. If he is moving to the left and I am moving to the left, hello. Wave at the people at home as we go by, right? We are speeding up. However, if, move that way, the velocity is moving to the right and the acceleration is moving to the left, he is going to be slowing down, and vice versa. If he's moving this way and I'm moving that way, he's going to be slowing down. Okay, thank you, Jackson. Okay, so speeding up versus slowing down. Let me write it right here. Speeding up when velocity and acceleration have same signs. So if the velocity is positive and greater than 0, and the acceleration is also positive, or velocity is negative and the acceleration is negative, the object is speeding up. Velocity and acceleration have the same sign. If they have opposite signs, they will be slowing down. So slowing down when velocity and acceleration have opposite signs. So velocity greater than 0, acceleration less than 0, or vice versa. Velocity less than 0 and acceleration greater than 0. You must justify them like this in terms of the velocity and the acceleration to get full credit. So if I, or perhaps more importantly, on the AP exam, they ask you a question, is the object speeding up or slowing down at t is equal to 5? You say the velocity at 5 is positive and the acceleration at 5 is also positive, showing your work. Therefore, since they are both positive, the object is speeding up. But you must mention the velocity and you must mention the acceleration. Okay? All right. Calculus yoga time. Stand up and stretch. Let's go. Move. Do a little aerobics. Do some core work. I need to treat y'all like the soccer girls. Do a little in and outs, crunches, bicycles, Russian twists. Fun, fun, fun. All right, we're almost done. Here we go. From the velocity graph, determine when the car sped up and when it slowed down. Okay, so first thing I'm going to do is label this so that I do not get confused. This is the velocity graph. I know this, number one, because they tell me, but even if they didn't, it's quadratic, right? And the position function was cubic, so this has to be the velocity graph. Therefore, it's going to cross the x-axis at 0.709, we found, and also 3.291. So let me go through this and then we will write it down. So from 0 to 0.709, my velocity, is it positive or is it negative? And how do you know? My velocity is positive. The reason it is positive is because this is the velocity graph and it is above the x-axis. My acceleration, however, is negative because I have a negative slope. Then from 0.709 to the minimum here at 2, velocity is below the x-axis. Therefore, velocity is negative. Acceleration is negative. They have the same signs. Therefore, the object is speeding up. From here to here, velocity is negative, below the x-axis. Acceleration, positive slope, slowing down. 3.291 to infinity, above the x-axis, velocity positive slope, acceleration positive, same signs, speeding up. Okay, so we say speeding up. From 0.709 to 2. And then from 3.291 to infinity. Because the velocity and the acceleration have the same signs. And then slowing down. From 0 to 0.709. And then from 2 to 3.291. And then I wrote myself a little note here on the velocity graph. Velocity is positive above the x-axis. And negative below. Acceleration is the slope. Yes.
So how come when this line down you start at 0 and you don't say negative?
Well, when does the time start?
Why is it not speeding up from 2 to 3?
Because my velocity is negative. Since this is a graph of the velocity equation, this is below the x-axis from 2 to 3.291. Therefore, the velocity is negative. However, my acceleration is positive because it has a positive slope. So they have opposite signs. Therefore, it is slowing down. But here, from 3.291 to infinity, velocity is positive above the x-axis. It also has a positive slope, same signs, therefore it's speeding up. Okay? So the last thing for today that we're going to look at here is this example. A particle P moves on the number line shown in part A of the accompanying figure. Part B shows the velocity of P as a function of time t. So this is my velocity equation. When is P moving forward? It's going to be moving forward whenever my velocity is positive. It's going to have a positive velocity when it is above the x-axis. So from 0 to 2.5, velocity is positive. It is moving backwards when the velocity is negative, so 2.5 to 6. When is the object slowing down and why? There's only one interval when it's slowing down. What is it? It's from 2 to 2.5. Here's why. That is the only time when the velocity and the acceleration have opposite signs. So from 2 to 2.5, my velocity is above the x-axis. It is positive. And my acceleration, it's got a negative slope. It's negative. So from 0 to 1, it is speeding up. Velocity is positive, and so is acceleration. It's also speeding up from 2.5 to 3. And then from 5 to 6. Velocity and acceleration have the same signs. And it is moving at a constant speed from 1 to 2. And then from 3 to 5. Because I am on cruise control in my Ferrari. Which does not mean that the velocity is 0. It means the acceleration is 0. But are they moving from 1 to 2? Does it have a velocity? Yes, it's 2 in this instance. Okay, we are going to stop there for the notes today, and I will finish those up mañana. You, on the other hand, are not going to take a nap.